All right, you guys, what's up? We're going to go ahead and take a look at the 3.1 to 3.4 review. If you guys understand this review, you are going to kill it on the test. All right? Great. Let's make a few notes here. Okay, first of all, if I am asked for the degree of a polynomial, do you guys remember what degree means? Okay, so degree means the highest exponent. So on this problem, okay, make sure it's in order. This is a third degree polynomial. All right. Okay, then we have this word, the leading coefficient. Remember, we talked about this in class. This is like the line leader. When we write it in order, it's the number in front of the highest exponent. So the leading coefficient here is -1. Okay, now we have these like limit questions. These can be a little confusing. Let me kind of explain to you guys what this means. When it says x go to infinity, okay, it means as x goes to the right, because those numbers are infinity, right? And where is the y value going? Down to negative infinity. Okay? So as x goes to the right, this goes down. And then as x goes to negative infinity, well, that's that way on my graph, which means as x goes that way. Where's the arrow on this one going? Up to positive infinity. Okay? So think of this as which way the arrow is going. As positive infinity is to the right, which way is the arrow going? To the left. It's going up. Okay? All right, great. Let's look at another question here. First, we have the degree, the highest exponent. That's 4. The leading coefficient. Guys, if you don't see one, remember there's always a little magical 1 hiding in there. The leading coefficient is 1. This tells me as I go to the right-hand side of the graph, okay? So as I go to the right-hand side of the graph, my arrow is going up. That's positive infinity. This is as I go to the left-hand side of the graph. As I go to the left-hand side of the graph, my arrow is going up. That's positive infinity. You could put the positive or you could just put infinity, okay? But basically it said it's going up, up, right? So it's infinity and infinity. The arrows are going up, up, okay? All right, and then we'll do one more of these. The degree is 3. The leading coefficient is -5. To the right, the arrow is going up. To the left, the arrow is going down. All right, so I can just kind of identify those different things. Pretty good so far. Okay, then we're going to have a little question on factoring. Okay? Now, you guys, if it just says factor, that's putting it in the parentheses. If it says solve, that's actually finding the answers, okay? So let's kind of take a look at some of these. Most of these are going to be these X problems where I say what multiplies to make 24 and adds to make 11. So in this one, it's going to be +8 + 3. So if the directions say factor on the test, if it says factor and that's not there, that's your answer, okay? If it says solve, we need to go one more step and make these -8 and -3 because that's actually my solutions. Okay, does that make sense? So let's look at our next one here. We have -16, +6. Let me actually move this over to the side a little bit. So what multiplies to make 16? We've got 8 and 2, +8 -2. Okay, again, if the directions said factor and that wasn't there, I'm done, right? If it says solve, it would be -8, +2. Okay, so hopefully you guys remember the difference of this. All right. 81 and 0. Okay, I have, what multiplies to make 81 and adds to give me 0? Well, it'd be 1 plus and 1 minus 9. Plus 9 minus 9 adds to make 0. Okay, so I would factor this as x plus 9, x minus 9. Because it says equals 0, I'm going to go ahead and solve it and say my answers are negative 9 and 9. Okay, what multiplies to make 20 adds to make 9? This could be minus 4 minus 5. Now, this doesn't have an equals 0 right now. So if it doesn't have an equals 0, I would leave it like that because that's factored. All right. But I'm going to go ahead and put an equals 0 right here. And I'm going to go ahead and solve it. And when I solve it, I would get 4 and 5. Okay. Let's see, this one is what multiplies to make 6 and adds to make 7. That's going to be positive 6, positive 1. So when I factor that, I get x plus 6, x plus 1. Okay, and it does say equals 0. So my solutions are negative 6 and negative 1. Okay, and then here's my last one of these, negative 60, positive 8. Now this one, it might take me a little bit of time. These are a little bit bigger numbers, right? As I'm thinking through here, if you guys don't get it right away, just start thinking what goes into 60, like 6 times 10, but I can't get 8 by adding or subtracting that, okay? Like sometimes I just start with 1 if I can't figure it out and go through. So on my calculator, if I do 60 divided by 1, that's 60, that's not gonna work. 60 divided by 2, that's 30. 60 divided by 3, that's 20. That's still not going to give me 8. 60 divided by 4 is 15. Ooh, I'm getting closer. It's still not going to give me 8, though. And I'm thinking 5. What is 60 divided by 5? 12. What on earth? That does not work either. 7, 8. Guys, I think that this is not factorable. Okay, and I was absolutely right. This is not factorable. I have a feeling that was a typo. I don't think we were trying to give you not factorable ones on this review sheet. You know, so we can always change that to something that actually does factor out. But that one is not factorable. You guys, you know how I'm going to have to do that problem? I would have to do it with the quadratic formula. Because it's not done by factoring. Okay? Okay, so let's go ahead and look at some quadratic formula questions. The first thing I want to show you guys is if you do see something like this, where like all the numbers are a multiple of 2, you don't have to do this, but it will make your life a little bit easier. I can actually change this problem to 4x squared minus 2x minus 9. Now, the reason that makes it a little bit easier, I just have smaller numbers. But, you know, 0 divided by 2 is still 0, so I'm still going to get the same answers, okay? And in here, I have A is 4, B is negative 2, C is negative 9. All right, so for my quadratic formula, I go negative B. I got to put negative, negative 2, okay? Plus or minus the square root of, and then on the inside, I need to do B squared. Now, don't write it like that, and especially if you're putting it in your calculator, you have to put a negative around it. So there's B squared minus 4AC all over 2A. You guys are going to have the formula there. You just need to know how to put it in and then how to solve it from here, all right? Well, what we're going to do is we're going to go, okay, so first of all, negative 2 is 2. when I go to see what's inside the square root, negative 2 squared is 4, minus a negative is plus, and then I'm going to go 4 times 9. And 4 plus 144 is 148. Okay? Now, I need to ask myself, all right, is 148 a perfect square? Which it's not, okay? Is it a prime number, or can I try to break it down? Well, I think we're going to be able to break this thing down, and I'm going to do that by, let's see, I don't know, I know 4 goes into it 37 times. You also could have done 2 because it's even, right? But look, I'm like using my calculator for this, okay? That's 2 times 2. 37 is a prime number that doesn't have any pairs. So look, I got a pair of 2s. All right. And so here's what I get. Okay, a 2 escapes, a 37 stays behind. And then do you guys remember on our last step, basically, we can reduce it if we do all 3 parts. So I go 2 goes into that 1 time, and 4 times. Okay, so my final answer is 1 plus or minus 1 square root of 37 over 4. That's going to be my final answer. All right. I think I wrote a little bit too big on that. Let me make this a little bit smaller. 1 second. All right, that's a little bit better. Okay, guys, let's go ahead and look at this next one. Now, you don't want to start your quadratic formula until everything is on the same side. So I want to move that 9 over. So now, look, I have A is 4, B is 4, C is negative 9. Okay? All right, let me zoom it a little bit here so you guys can see this. Okay, so negative B plus or minus the square root of B squared minus 4AC all over 2A. Okay? Now remember up here, I like to go like this. 4 squared is 16, minus a negative is plus. So this time I have 4 times 4 times 9 is 144, plus 16 is 160. Okay? Now, I look at this number and I go, is that a perfect square? Okay, which it's not. 160 is not a perfect square, but it does break down. Let's see. Let's start with 16 times 10. That's 2 times 8. That's 2 times 4. That's 2 times 2. 2 times 5, okay? So I've got a pair of 2s, 1 dies. So sad. A pair of 2s, 1 dies. Okay, that 2 and that 2 escape from jail, join up, make 4. That 2 and that 5 are left in jail, and it's all over 8. For my final answer, I'm just going to check, can all 3 of these divide by one single number? Yeah, they can all divide by 4. So I am left with negative 1 plus or minus the square root of 10 over 2. Okay, once I reduce that down. All right? So a couple of questions there where we needed to reduce those. Okay, let's take a look at letter C. These are all nice in order here. This is A, B, C. So here's what we got. Negative B plus or minus B squared minus 4AC all over 2A, which is 9. Okay? Okay, so let's go ahead and say what is in our square root. Well, 4 squared is 16 minus a negative is plus. 4 times 9 times 16 is a pretty huge number. 576. And if I add those together, I get 592. And I have 18 on the bottom. Okay? That's a big number. And I just think that it's going to reduce. I'm going to go ahead and try it anyway because it can divide by 2. If it's even, you guys, just divide by 2. Get your calculator. Go 592 divided by 2. That's 296. Divided by 2. That's 148. I don't know why I put it that way. Hold on. Divided by 2 is 148. I'm going to start making it go down like this or I'm going to run out of room. 148 divided by 2 is 74. 74 divided by 2 is 37. So I have a pair of 2's here and a pair of 2's here. All right? So 2 times 2 is 4. So I end up getting negative 4 plus or minus 4 square root of 37 over 18. I check if I can reduce. All right. And I can reduce all of those to 229. Okay. So that's my final answer. Negative 2 plus or minus 2 root 37 over 9. All right, and let's check out our last quadratic problem here. Okay, so we have A, B, C. I'm going to go ahead and go negative B plus or minus the square root of B squared minus 4 times 8 times 5, that's 4AC, all over 2A. Okay? Okay, to see what's inside the square root sign, 6 squared is 36. Use my calculator here. Minus 4 times 8 times 5 is 160. And 36 minus 160 is negative 124 all over 16. Now before, you guys might have been like, oh shoot, I can't square root of negative. There's no real answer, right? Well, there isn't a real answer, but there is an imaginary answer. So we're going to keep going with this. We're going to break down the 124. I know that divides by 4. Don't worry about the negative for now. 4 and 31, 2 and 2. Okay? So look, here's how I'm going to write this. Negative 6 plus or minus. The 2 escapes. The negative tells me I, and the I comes to the outside. But then the 31 is left in jail. Now, when I look at those numbers and see what do they all reduce by, well, these all reduce by 2, 3, 1, and 8. Okay, so my answer will be negative 3 plus or minus 1i square root 31 over 8. So with your quadratics, you can have imaginary numbers too, if it turns out like that. All right? All right, guys, let's take a look at number 6. So if you remember that whenever we have square root of a negative, that means I. Now let's look at these different types of problems we have. This is a perfect square, right? The square root of 1 is 1, so it's 1i. You can just put I if you want. Okay? The square root of 4 is 2, so that's 2i. The square root of 100 is 10, so that's 10i. Now, the rest of these, well, these are not perfect squares, all right? Which means I need to simplify them. They're still going to have an I in it because of the square root of a negative, but let's look at how I would simplify this, okay? Okay, 18 is 2 times 9, 3 times 3. I have a pair of 3's. So here's how this works, okay? The 3 escapes from jail, the 2 stays in jail, and because of the negative, I have an I. All right, let's try the same thing on letter E. 75. Now, if you don't know, if you're not sure, divides by 5. You can use your calculator. Divides by 3, right? 325, 5, 5. Okay? And then I get 5. Negative is I, and the 3 is left in jail. Okay, you guys, it's not wrong if you put the I over here. You just really have to be careful. If it looks too close in there, it is wrong. It needs to be well out of the square root sign, but that's why I just like to leave it right there. All right. Okay, now look at this one. This one's fun. All sorts of numbers and letters plus an I in here. Okay. 12 is 2 times 6, 2 times 3. We got a pair of 2s. All right. So there's a 2 outside, a 3 inside. Okay, I'm gonna leave lots of room. I can go ahead and put the I right now, just so I don't forget about it. Now I have X. I'm kind of doing it in the same way, right? I'm breaking it down, but look, there are 4 X's. So if I look for my pairs, I have 2 pairs. That one dies, that one dies. So there's X squared, none left. Okay. Now I'm going to look at my Y's. I have 6 Y's. Pair, 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 cancel, cancel, cancel. So I have 3 Y's that escaped from jail, and actually, oops, none left. Okay, so that's my final answer for that one. All right? So hopefully those make sense. Don't forget to include your I in your answer. All right, next, let's talk about powers of I. You guys remember how this goes. Okay, I will likely give you this chart, just in case you don't remember. I is I squared is -1. Remember, that's a really important one. We're going to use that a lot. I to the third is that times that, so it's -I. I to the fourth is I squared squared, so that's positive I. Okay, so this is my chart of I's. All right. I squared, that's small enough to look at the chart. That's right here. That's -1. I to the third, I can go ahead and look at the chart. That's -I. I to the fourth, I can look at the chart. That's 1. Now we start getting these bigger numbers, you guys. Okay, you can count them. You can go like this. This is I 1, 2, 3, 4. This is I 5, 6, 7, 8. This is I 9, 10, 11, 12. So I 12 ended up in the same spot as I 4, which is 1. But do I actually want to sit here and count to I 38? Probably not, right? So what you're going to remember is, like, if you do start counting through these, you guys, the bottom number is always a multiple of 4. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oops, I 16, and so on. Okay? But it's always a multiple of 4. So if I'm trying to find, like, I to the 38, I think, what's the closest multiple of 4 to 38? Now, you could pick 36, you could pick 40, it's like completely up to you. Let's say I pick 36. Okay, it would go like this. I 36 goes there. 37, 38. So this one is I 38. So it's -1. Let's say instead of 36, you picked 40. Okay, that's actually fine because look, 40, now go backwards, 39, 38, and I still end up right there with -1. All right, so it's all about just counting your multiples of 4. I mean, I guess when in doubt, at least just pick one of those 4 because that's always going to be one of your answers, all right? You guys, conjugate pair, the word that we can kind of use to remember that, conjugate pair, we're just going to remember that that means opposite. Okay, and what that means is I actually want to do the opposite of the sign in the middle. So when we're solving things, we always say that imaginary numbers come in pairs. So here are the pairs. 2 plus I pairs with 2 minus I. 5 minus I pairs with 5 plus I. -9 plus I pairs with -9 minus I. Okay, so those are the pairs. Those are just the answers that would like go together. All right, now before we do graphing, we're going to do a couple of operation questions, adding and some multiplying, okay? Guys, when you're adding, it's basically just combining like terms. Okay? So let me combine the real parts first. 2 minus 5 is negative 3. Now let me combine the imaginary parts. I plus I is 2i. All right, when you are multiplying, these two are both multiplying, I highly, highly recommend using the box. Make your life a ton easier. Okay, so I have 1 and minus 2i on the top, 7 and plus I on the bottom. Okay? 7 times 1 is 7. 7 times negative 2i is negative 14. I times 1 is 1i. And I times negative 2i is negative 2i squared. Now, when we're doing these operations, you guys, we have to remember something really, really important. I'll go ahead and write it over here. I squared is negative 1. And when I'm doing these multiply problems, that's actually going to make a pretty big difference, okay? Because it basically tells me to take that, and instead of being negative 2i squared, it's negative 2 times negative 1, which switches it over to plus 2. So I squared will change the sign of things. Now, let's go ahead and add the real numbers. Okay? 7 plus 2 is 9. Now let's go ahead and add the imaginary numbers. Those are on the other diagonal. Okay, 1 minus 14 is negative 13i. All right, and then that's how we'll do that. So let's go ahead and practice this one. We're going to make another box. We're going to do 8 minus I, and we're going to do 8 plus I. Okay? Okay, 8 times 8 is 64. 8 times negative I is minus 8i. 8 times positive I is plus 8i. And I is negative I squared. But I then remember that I squared is negative 1. So negative negative 1 turns into plus 1. Okay, now check this out. Let's do the real numbers. 64 plus 1. Okay, so that's going to equal 65. Let's do the imaginary numbers. Negative 8i plus 8i. Hey, those actually cancel out, right? I can actually just cross those out. And so my final answer is just 65. Okay? So that's how we do multiplying. All right, last but not least, on your test, you will have one of each type of quadratic. Okay? All right, my first quadratic right here, this one is in standard form. And the thing I want you guys to remember about standard form is the vertex, we'll write some notes over here, is negative b over 2a. So remember how we have a, b, c? All right, that's a is 1, b, c. So it's negative b over 2a, which gives me negative 2 over 2, which gives me negative 1. Okay, you guys, that's the x coordinate of the vertex. All right. Now, we need to find the y coordinate, and the only way that we can do that is we're going to take this negative 1 right here, and we're going to plug it in. Okay? If you need to use a calculator, you can go use a calculator or whatever. When I plug in negative 1 squared, I get 1. 2 times negative 1, I get minus 2 minus 8. And 1 minus 2 minus 8 is negative 9. So I'm going to go ahead on this graph, and I'm going to put a point. Negative 1, negative 9. And then if you want, right, you can draw this line that we've been using right down the middle so we can see this like axis of symmetry. Okay, just so we can see that everything's going to match up. So that's the vertex in standard form. Okay? For the X-Intercepts in standard form, we want to factor. We just want to factor and solve, okay? So let's go back up to this equation right here. There's something that multiplies to make 8 and subtracts to make 2. 4 and 2, right? Plus, minus. Now, if it factors to x plus 4, x minus 2, remember that the x-intercepts are the opposite. They're negative 4 and 2. I mean, you can write them as coordinate points if you want, but you can also just write it as this, and that's fine. So negative 4 and 2. If you guys look at that, are we looking good so far? We're nicely spaced out, okay? So that looks good. Okay, the y-intercept, no matter what kind of problem you're doing, you plug in 0 for x. Okay, guys, so when I plug in 0, I get 0 plus 0 minus 8. And actually, the thing about standard form is you can actually see the y-intercept. It's the number on the end. So if you remember that, then that's fine. My y-intercept is 8, okay? Negative 8. So now I come over to my graph. There's negative 8. And then you guys remember we do a point directly across from it, the reflected point. And I've got all my points here. And I can draw this lovely graph. I'm going to draw this in. Okay, once I draw my graph, let's answer these questions. All right, what is the domain of that graph? Well, you guys, every parabola, negative infinity to infinity. What is the range? Well, just look right here. The lowest it goes is negative 9. So this one's going to go bracket negative 9 to infinity. Does it have a maximum or minimum? Well, if it's a right-sided parabola, that point right there is a minimum. What is the maximum or minimum value? You could just put negative 9. All right, or if you want, you could put the coordinate point, negative 1, negative 9. Like, I'm okay with either one, but that's the minimum value. It's the exact same thing as the vertex, okay? So that is standard form. Hopefully you guys remember all those different things, all right? Okay, next, we're going to look at vertex form. Okay, now, the thing we like the most about vertex form is the fact that I could see the vertex. The only thing I need to remember is it goes opposite, same. So the vertex is 3, 1. So there's the vertex, okay? Now this one's a little more difficult when we're finding x-intercepts. It's like slightly more difficult. Remember, we're going to set it equal to 0 and try to solve it. And the way we solve these is with square roots. Okay, so let's go ahead and take this equation up here. All right. This is a very awful question. All right. Let's move along here. You guys, to be totally honest with you, there's no way I would give you a question like this. Absolutely not. But let's just work through it anyway, okay? Just so you guys can kind of see the steps. All right, look. Subtract 1 from both sides. Negative 5, x minus 3 squared equals negative 1. Divide both sides by negative 5. Okay, and so what happens is I end up getting x plus 3 squared is 1/5. Well, 1/5, let me just do that on my calculator if you don't mind. 0.2, all right? So when I square root that, I get plus or minus. Now this is the part you won't have on your test. You'll have a regular number like square root of 4, square root of 9. Okay, this is not a regular number. The square root of 0.2 is 0.44, all right? But just pretend like that was a regular number, okay? And then I'm going to subtract the 3 over. All right, so here's what I get. Take the positive first, Again, on my calculator, but remember, you guys will have nice numbers. Positive 0.44 minus 3 gives me negative 2.56, and then I'm going to take the negative. Negative 0.44 minus 3 gives me negative 3.44. So I'll go ahead and write those down for my intercepts. But remember, are you going to have decimals on your test? No, I will make it come out nicely. Okay? This is kind of a, a little bit of a pain to do this. Okay, I can still figure this out though. Whoops, look at what happened. I made a mistake right here. I changed that x minus 3 to an x plus 3. I don't know why I did that. That was a mistake. Let me go back and fix that real quick, guys. So I actually am adding 3 to both sides. Dang. All right. You know how I caught that mistake, you guys? You know how I caught that? So you'll do this. We've talked about this in class, right? I caught that. I was like, okay, I'm going to go put this over here. Negative 2.5 and negative 3.4. Is that going to make a parabola, you guys? Did we not look at this in class and went like, that's not a parabola. So I was like, shoot, I made a mistake. I looked over here and I found my mistake. Okay, and then I'm going to go back and fix it. All right. So that's good. Like, it happens to me. It happens to all of it. Like, we're going to make mistakes on here. We're going to miss things, but you can catch it if your graph starts looking weird, right? Okay. Positive 0.44 plus 3 is 3.44. And I'm going to do negative. Negative 0.44 plus 3 is positive 2.56. Ooh, that is so much better because 3.4 and 2.5, does that look pretty symmetric if I take this right down the middle? It does, okay? Okay, you guys will love this. Here's another reason why I wouldn't exactly use this question to make you guys graph. Check out the Y-intercept. Okay, remember the Y-intercept is when we plug in 0? All right, let's see. Okay, negative 5. 0 minus 3 is negative 3 squared is 9 plus 1. So that's negative 45 plus 1. So my Y-intercept is negative 44. What is happening here? We should have probably picked some better numbers for that. Okay, negative 44 is like down there. And then I'll do the same thing on the other side. And then there's my beautiful parabola. Okay, that's like not so beautiful, but you guys get the idea. Oops, that certainly doesn't look nice. Okay, but you guys get the idea. All right. We'll work on a better one than that in class, but there you go. Okay, what is the domain? Negative infinity to infinity. What is the range? Well, the highest number it goes to is 1. So negative infinity to 1. This has a maximum because it's an upside down parabola, and the highest it goes to is 1. So you could say the max is 1, or you can put the coordinate point. Either one is okay. All right? Kind of a crazy one. Remember, I'm not giving you decimals. I'm not giving you Y-intercepts of negative 44. But if you guys follow the process, you're good. All right, we have made it to our last question. Our last question is in factored form. Now, the thing that is really different about factored form is we start here first. It's the only one where we don't start with the vertex. We actually start with this. Oh, gosh, another one that I'm not incredibly thrilled with. You know what? Let's go ahead and change this problem to a 4 right here. Can we do that? Well, no, it's fine. I'll do it like this. On the test, it'll be easier. I'll just say it that way, but this is okay. All right, let's just go with it. The X-intercepts then would be positive 1, negative 2, okay? So positive 1, negative 2. Why was I going to tell you that we should change this? Well, because look, guys, halfway between that and that is a half, which is a little bit of a bummer, but it's fine. I will make sure again on the test that it goes to one of the whole numbers, okay? So this is negative 0.5. Now, how do I find the other part of the vertex? Well, I'm going to plug in negative 0.5 here and here, okay? So I'll do it on my calculator. Negative 0.5 minus 1 is 1.5. Negative 0.5 plus 2 is positive 1.5. And if I multiply those all together, I get 6.75. So again, it's not great. It's decimals. It's okay. We'll make it work, all right? 6.75 is about right there. Okay, the last thing I'm going to find is my Y-intercept. All right. That's where I plug in 0. Okay, so let me move these out of the way. If I plug in 0, I get negative 3. Okay, 0 minus 1 is negative 1. 0 plus 2 is positive 2. A negative times negative is a positive. 3 times 1 times 2 is 6. So let's go ahead and put that at 6, and I'll write it on the other side at 6, and then I'll get my graph. Okay? Look, guys, the domain of this, negative infinity to infinity. The range, negative infinity to, what's the highest that it went right there? Do we remember? 6.75. And it has a maximum at 6.75. Okay? So hopefully that helps you guys get ready for this test that we're going to have, and hopefully it all makes sense.